specifically talking about problem solving, whereas section 1.8, we looked at the setup of problem solving. We set up the equation, we didn't always solve what was needed. Okay, and if you recall, look at the last question in your test, we didn't really go into the actual answer. We just set up the problem. Now, we're going to look at problems where we're actually going to go ahead and solve them. Okay? First example. Jeff, why don't you read, Jeffrey, read it for us nice and loud, please.
Each of the base angles of an isosceles triangle has a measure that is 30 degrees less than a measure of vertex.
So it's isosceles, right? And isosceles means two sides are the same. So right away, draw yourself something that looks to at least have two sides the same. Now, give me some labels. Use directionals like top angle, bottom left angle, bottom right angle. Tell me what I should label these as. Nigo.
The two sides, two equal sides should have one line.
You could do that first to show that they're equivalent. Good, that works. We should know our symbols. Now, a lot of these symbols you can also learn in geometry, so don't worry too much about this right now. But you should know what an isosceles triangle is at this point in your life. You should know what a scalene triangle is, an acute triangle, okay, obtuse triangle. What do I know about my let statements and my dimensions and my angles? What can I write on here? Well? The bottom two angles are definitely the same. Those are equivalent to one another. Good. What's the measure of angle A? What's the measure of angle A according to this? And you could use a variable in it. All right, so let's call C x for now then, okay? So x minus 30, that works. X minus 30. The measure of angle B is the same as A because it's isosceles. And then we started by saying let C be just x at the top there, so it makes it easier. So there's our three angles, x minus 30, and x. What do we know about the angles of a triangle? I hope we learned this in middle school. It's possible you didn't. If you didn't, at least jot it down. Emily? Yeah, they sum to equal 180. They sum to equal 180. So we go ahead and just simply write x minus 30 plus x minus 30. Now I'm going to show in a moment, obviously, that parentheses is not really needed. Equals 180. I started by putting parentheses there simply because I knew I was adding quantities together. But when you're adding things together, you can drop parentheses always. It's only if you have multiplication involved that you need the parentheses, really. How many x's do we have? 3. So we have 3x here. Minus 30 is minus 60, equal to 180. And then algebra is easy at this point. Add the 60 over and divide by 3. Okay, again, I'm not really showing the steps here, so I'm verbalizing. I'm telling you in words what I'm doing, so ask me a question if it doesn't make sense. Am I done? What did the problem ask for? What did it ask for, Alex?
Find the measure for each angle.
Each angle. So which angle is that, Alex?
C.
Good. The vertex. Very good. C. Angle C. That should say 80, sorry. How about the bottom two angles? What are those going to be?
50 degrees.
Yeah. Where are you getting 50 from, Will?
80 minus 30.
Good. These are 80. This is 80. This was the vertex angle minus 30. So 80 minus 30 gives us 50. We also know that if it's isosceles, obviously it has to be the same at the bottom and it has to add up to 180. Okay, so there's our final diagram. Okay, so A is 50, B is 50, and C is 80. Pretty easy for a beginning problem, okay? Definitely expect a problem like this on an SAT test where they give you some part of an angle in terms of the other angle. Okay, it says like one angle is half the other angle. or one angle is 40 less than twice the other angle, get used to that setup, where you then sum them together to add up to 180. Let's try the second for a second. Okay, turn to the person next to you. Maybe you guys here, 2 there, 2 here, and then Sarah and Jeffrey work together there. Okay, work on this one with the person next to you. Spend about 5 minutes at least. Try and come up with let statements. Go through the whole process. See how you would do on this. So income from the adult tickets, that's right here. Okay, 200 tickets sold. Was, which is the equal sign right there, 30 less than, that's 30 less than, 30 less than twice the income from the children. The income of the children is 160x. So 30 less than twice that. So you're literally taking that sentence that I'm using that sentence to read that equation. So my recommendation is read the sentence twice or twice. Make sure you can identify which part of the sentence comes in this equation. That way you can tell us to explain that. So you're good at starting. You're good at starting. Where'd you get that? You got that from this part. The income from the adult tickets. And you see was means equals. So this is good. Then it says 30 less than. So what I would do is erase this piece right here. And when I use 30 less than, I know it's going to be minus 30. So put a minus 30 again. There's 30 less than. And if 30 less than twice, children. What's the children's income? I'm using the terms of X. X is the children's tickets, right? How many tickets? Remember, the price for each children's ticket is X, right? And how many tickets were sold for kids? So 160X is going to go here, but you need twice that. Okay? There it is. Remember, this is not distributed here. 2 times 160 is 320. This is 320X. You're not distributed. Here you are. So I want Emily, you to understand that. Okay? So I have to come over and explain check the one first. And I want her to be able to explain what she did. And if you're the same thing, then make sure you all understand why you're the same thing. So, Chandler, I want you to go over James here. James is presented to you, but I want you to make sure that what he's saying is right. Tell me what's right. You agree or not? So, Christian is going to explain it to you guys. And you need to tell him if he's right or wrong. You ready? Oh, there we go. Did you have the exact same thing? Identical with them? Nice. Double ticket sold, minus 30. Shorten them. Awesome. Hold on. Okay. You can go on to the next one.
Are we finding the answers?
Yeah, eventually, guys, you're going to solve for X. Yes. You can continue to solve and go through the process. Well, what was your last name? What was X?
Oh, so that was for children, adult.
X was for children. Remember in children, so 160? And X was the ticket?
Oh.
X is the cost of the children. So the adult ticket is the alpha stack.
Oh.
Okay, that's right at the beginning. That's let X equal. Hey, everybody, listen up real quick. You should all have started with let X equal the cost of a child's ticket. Let 150 plus X equal the cost of an adult ticket. Not the number of adult tickets or children's tickets, but the cost of each. The reason I'm emphasizing writing let statements is so when you get X in the end, you remember what X was defined as in the beginning. X was defined as the cost per child ticket. So a lot of you already got, what was it again, Jim?
275.
275 for the children's ticket, right? So you're getting 425 for the adult ticket? Okay? Go on to the next one, please. Go on to example number 3. Christian, slide over this group. James, slide over this group this time. At this point in time, you should have something like this on your diagram. Take a look and see if it's close to these. We're told that the side of the square, called S or X. The base of the triangle is 4 less. The sides are 9 longer, sorry. It should be plus there. Those should be pluses. Sorry, these are pluses. Now, what do you know from the very beginning? This is the one kicker. The wire was, yeah, they're both equal length. So what statement could you write right now? Since both wires are the same.
4x equals x plus 9 plus x minus 4.
Yeah, so generally speaking, the perimeter of the square equals, yes, the perimeter of the triangle, because the perimeter is really the wire. The wire that you bent into the shape, the physical wire. I should have brought wire. There's so much wire in this story. I should have brought it over. I should have given you. Next time maybe I'll think about that. Yeah. Could have given you wire. You could have turned it on yourself. But physically speaking, it's the same piece of wire. So you're bending the wire into the perimeter, so set the perimeters equal to one another. Okay, the perimeter of the square equals the perimeter of the triangle. Then from there, as Emily said, it's pretty straightforward. So how long is the wire? James?
14, 7.
The wire?
Wait.
You got it, I know.
14, 56.
There it is. See, so it's important, again, that I recall, or I remind you, your let statements are huge. X was defined as the side of the square. So, although x is 14, the answer is 56, meaning 14 plus 14 plus 14 plus 14, or 14 times 4. Okay? You could have used it for the triangle also. It works the same way. 14 plus 9 plus 14 plus 9 plus 14 minus 4, you'll still get 56. Is that clear? Last one's a little tricky, so I'm going to do it as a class. Christian, read it for us, please.
A truck left New York City at 2 o'clock p.m. for Queensburg, traveling at 40 kilometers per hour. At 3:15, a car left Queensburg for New York City at 55 kilometers per hour. The truck and car passed each other exactly 2 hours after the car left Queensburg. How far is it from New York City to Queensburg?
So here's what's happening. Why did I draw this in little segments? Why did I draw the guy leaving New York, leaving, and then I put another dot and started like another little ray next to it? What's the whole idea behind that?
The second dot is supposed to represent the same time that the other car left.
Yeah, look at the problem. The guy in New York leaves an hour and 15 minutes earlier. Doesn't mean he gets a head start. So that first little ray right here is the distance covered in 1 hour, 15 minutes. In the very beginning, for that first hour and 15 minutes that the truck leaves New York, he's got a head start. And he's traveling at 40 kilometers an hour. Okay, he's traveling at 40 kilometers per hour for that beginning part. Then 3:15 starts, or he is 3:15. He's at some location now, and they both take off. And they both start traveling toward each other. And that happens, and the car leaving, Queensbury, travels at 55 kilometers per hour. But I'm not going to write any more detail for him, because at this point it's like the problem had started over. They pass each other 2 hours after the car leaves Queensbury. So not after 2 hours from the beginning, but 2 hours after that 1 hour and 15 minute delay has already occurred. So this truck leaves, spends an hour and 15 minutes, then the car leaves, and after 2 hours they somehow meet in the middle. The question is, where are they going to meet? Where are they going to meet? Okay, how far is it from New York to Queensbury? How do we figure this out? How can we figure this out? Jeff?
So, the time after the first trip from New York to Queensbury, before the Queensbury car left, was 50 kilometers.
50 kilometers. Can you tell us how you got that, just so we know?
40 kilometers per hour times
1 point.
1.5.
Where's the 1.25 coming from? We need to just make sure everybody's clear.
15 divided by 60 divided by.
So you have an hour and 15 minutes. 15 minutes of an hour is another quarter of an hour. Is that, we're all clear on our fractions there, right? 15 minutes is a quarter of an hour. So by multiplying these two, what'd you say again, Jeff? You got 50? 50 even, it should be actually, yeah, 1 1/4. Perfect. So it was 50 kilometers of a trip in the beginning. That's the first segment covered in an hour and 15 minutes. In an hour and 15 minutes, it literally covered that much. Now, the question is, how far is it from New York to Queensbury? So we also need to figure out how far it is between these two blue lines I'm now drawing. How far is it between those two blue lines? How can we figure that out?
It tells you their rate and how long they're at.
All right, so it tells you that it takes how long before they...
2 hours.
2 hours. So the time it takes for these two to collide, in a sense, is 2 hours. What rate do I use, though?
I mean, if you different rates, different averages too. Or
Sure.
you just use like both.
Which one do you want to do? Either works. You pick. What's this rate going to be here? What do I fill in that one? Okay. So this guy travels at 40 kilometers per hour for 2 hours. So how long is that distance going to be there? 80. So there's our second segment of distance, D2. D3, How fast does the car leaving Queensbury travel at? What do we have for that piece? 55, okay, that works.
110.
For how long? 2 hours? Giving us 110 kilometers. So what happens again is that this person travels for a while by himself, 50 kilometers, to cover some gap. Then they both leave. So if you wanted to know where do they physically meet, you could figure that out as well, right? How far from Queensbury do they meet each other? How far from Queensbury do they meet each other? Jeffrey? 110 kilometers. Queensbury is right here. They meet up right here, which is 110 kilometers away. Or you could say from New York, it's 130 kilometers. Again, 130 kilometers, 50 plus 80, from New York, or 110 coming from Queensbury. So overall, in the end, you just still need to add them all together. Okay? So 80, 110, and 50. Now, what Anigo was mentioning was this, guys. You could add these rates together. See 40 here? And this 55? If you add those together first, and then multiply by 2, you get the same answer. You just get the sum of these two numbers. Okay? Because remember, when two objects are coming toward each other, if I'm running at James with 5 miles an hour and he's stationary, it's no big deal. But if he's running at me at 5 miles an hour and I'm running at him at 5 miles an hour, it's like we're really running at 10 miles an hour. Because we're both covering the gap every time. Right? If James is here and I'm running at him, nothing's happening besides me running. But if he's running at me and I'm running at him, now we're closing the gap much quicker. So it's like an increased rate. Okay, 240 will be your answer. You have 5 homework problems for this.